Very good morning, students. Today we are discussing a new chapter, Surface Chemistry, video 1. In PU board exam, the weightage is 6 marks. 1 plus 5. 1 mark question, 1 5 marks question, total weightage 6 marks. The first question in examination point of view, define the following terms. Any one definition they will give student. Nearly 6 definitions are there. We are discussing one by one. Directly I will write the answer. Define the following term. First one, adsorption. Adsorption. The phenomenon of accumulation of molecular species, that is gas, liquid or solid, on the surface of another substance like liquid or solid are known as adsorption. The phenomenon of accumulation of molecular species like gas, liquid, solid on the surface of another substance like liquid, solid are known as adsorption. Let us consider, student, the blue color line is the surface. The another color is accumulated on the surface of blue color line. Hence, this phenomenon is known as adsorption. This phenomenon is known as adsorption. The blue color line provides surface area for adsorption. The another color accumulate on the surface of blue color line. Blue color line. Here important, student. The molecular species which accumulate on the surface of another substance, either gas or liquid or solid. The surface which provide the substance which provides surface area for the adsorption, always liquid or solid, but not gas. The substance which provides surface for adsorption phenomena, always liquid or solid. Whereas the substance which is accumulated on another surface, always either gas or liquid or solid. Remember, student, absorption is an exothermic process because when molecular species accumulated on the surface of another substance, some amount of energy will be liberated. Hence, absorption is an exothermic process. During absorption, change in enthalpy delta H decreases, change in entropy delta S decreases, change in free energy delta G will be decreases. That is, delta H is negative, delta S is negative, and delta G will be negative. Because when molecular species accumulated on the surface, some amount of energy will be liberated. When molecular species accumulated on the surface, the orderness increases. We know that entropy is a measure of disorderness. Disorderness increases, entropy increases. Disorderness decreases, entropy will be decreases. Here, when molecules accumulated on the surface, disorderness decreases. Hence, the change in entropy will be decreases. Change in entropy will be decreases. Once again, repeat, student. When molecules accumulated on the surface, what happens? The orderness increases, disorderness decreases. Entropy is a measure of disorderness. Here disorderness decreases means entropy also decreases. And if delta H is negative, delta S is negative, according to thermodynamics, by using the equation delta G is equal to delta H minus T delta S, delta G will be negative. Right, student? In our board point of view, they will ask like, what are the values of change in enthalpy, change in entropy, change in free energy during adsorption process? 1 mark question directly, student. Delta H, delta S, delta G all are negative only. Okay, students? Right. Next one. Adsorption is a surface phenomena. The molecular species accumulate on the surface of the substance only, but they are not enter into the inside of the substance. Hence, adsorption is always surface phenomenon. Adsorption is always surface phenomenon. Next, it is fast at the beginning and gradually becomes slower. Why? Because at the beginning so much space is there for adsorption. It is fast at the beginning. Why? Because so much space is available. But after some time, total space is occupied by the molecular species. Hence, space is not available. Hence, it becomes slower. At the beginning, so much surface area is available for adsorption. Hence, it will become fast. As the surface is completed, Hence, the substance is not absorbed. The substance is not absorbed. That's why the absorption process is fast at the beginning and gradually becomes slower. Gradually becomes slower. Copy this, student. Okay, next definition, student. Adsorbate. Adsorbate. The molecular species that accumulate on the surface of another substance are known as adsorbate. The substance that provides surface area for adsorption are known as adsorbent. Adsorbent. Adsorption process contains two components. One is adsorbate, next one is adsorbent. The molecular species that accumulate on the surface of another substance are known as adsorbate. The substance that provides surface area for adsorption are known as adsorbent. Let us consider the mixture of hydrogen, oxygen, ammonia and carbon dioxide gases present in a closed container. When charcoal is added to the mixture of these gases, what happens? Before addition of charcoal, the pressure of the vessel is 4 atmosphere because these gases applies pressure on the walls of the container, like hydrogen, oxygen, ammonia, carbon dioxide gas applies pressure on walls of container. After addition of charcoal, these four gases adsorbed on the surface of charcoal. Hence, container does not contain any gases. Hence, the pressure is reduced to 1 atmosphere, that is atmospheric pressure. Here, it is the charcoal. When charcoal is added, these four gases are adsorbed on the surface of the charcoal, like this. Adsorption is a surface phenomenon. Hence, the container does not contain gases, they does not exert pressure. In examination, they will ask like this, student, based on this concept adsorbate and adsorbent. When the mixture of the following gases like hydrogen, oxygen, methane, carbon dioxide in a closed container, to this closed container you can add charcoal, what happens? What happens, student? The pressure of the container will be decreases. The pressure of the container will be decreases because these gases are adsorbed on the surface of the charcoal. Next, students, and one important, adsorbate may be solid, may be liquid, may be gas, whereas adsorbent liquid or solid but not gaseous. Remember the student. Solid adsorbents can act as good adsorbents in finely divided state because surface area will be increased. Remember, students, if the surface area increases, adsorption phenomena increases. Surface area decreases, adsorption phenomena will be decreases. Let us consider solid substance. This is surface area. If this solid substance make in the form of powder, then the powder can occupy more surface area when compared to the solid. Hence, that is can act as the good adsorbent. For example, piece of chalk can occupy some surface area. If the piece of chalk make powder, that can occupy more surface area when compared to solid form. Hence, a good adsorbent like this. Solid adsorbent can act as good adsorbent in finely divided state because surface area will be increases. In PU board, one more question they will ask student. Why solid adsorbents can act as good adsorbent finely divided state? Because the reason will be surface area increases. Other form they will ask student. The solid adsorbent can act as good catalyst in which state? Finely divided state can act as good catalyst. Okay, student. Next definition, desorption. The process of removing adsorbed substance from the surface of adsorbent are known as desorption. This adsorbed substance removed by heating process, by electrical process, this is known as desorption. Accumulated on the surface, adsorption. Removed from the surface of adsorbent, desorption. Adsorption and desorption are opposite to each other. For this one example, if you rub the board with normal duster, then what happens? The dust particles, the white chalk dust particles adsorbed on the surface of the duster, but they are not enter into duster. When you bombard the duster with a wall, the dust particles moves away from the duster. That is known as desorption. Adsorption and desorption. When you rub the board with the duster, adsorption phenomena takes place. That is, the dust particle accumulated on the surface of duster. When you bombard the duster with a wall, the dust particles are moved away from the duster. That is known as desorption. Hence, the process of removing of adsorbed substance from the surface of adsorption are known as desorption. Copy this, student. Next definition, students. Absorption. The phenomenon in which the molecules are penetrating into body of the substance are known as absorption. Not adsorption, student. Absorption. The phenomenon in which the molecules are penetrating into the body of substance are known as absorption. For example, water taken a sponge. When a sponge dipped in the water penetrating into the sponge, that is known as absorption, but not accumulated on the surface, which is known as absorption. Okay. Once again, the phenomenon in which the molecules are penetrating into body of substance. Water absorbed by a sponge or water taken by a sponge. Sorption. The phenomenon in which both adsorption and absorption takes place simultaneously are called sorption. The phenomenon in which both adsorption and absorption takes place simultaneously are called sorption. Next, second question, students. In board point of view, 2 times this question is given. Name the factors which influencing adsorption of a gas on solid. Name the factors which influencing adsorption of a gas on solid. First factor, nature of adsorbent. The adsorbent in finely divided state is a good adsorbent because surface area will be increases. The adsorbent in finely divided state can occupy more surface area when compared to the normal solid state. That is nature, student. Nature of adsorbate, that is the substance which is adsorbed on the surface of another substance. Nature of adsorbate. Here one important thing is, a student. The molecules, the adsorbate molecules which are easily liquefiable is highly adsorbed on the surface of adsorbent. Easily liquefiable gases are more adsorbed on the surface of adsorbent. Let us consider sulfur dioxide, whose critical temperature is 630 Kelvin, and hydrogen, whose critical temperature is 33 Kelvin. The critical temperature directly proportional to liquefaction of gases, which is directly proportional to adsorption of gases. Easily liquefiable gases are more adsorbed on the surface of the adsorbent. Therefore, critical temperature Tc is directly proportional to adsorption of the gas. That is, in examination they will ask like this. When 2 gases separately adsorbed on the surface of solid or adsorbent like sulfur dioxide and hydrogen, whose critical temperature are 630 and 33 Kelvin, which gas is more adsorbed on the surface of the adsorbent? Sulfur dioxide is more adsorbed, student, because as the critical temperature increases, liquefaction of the gas increases. As liquefaction of the gas increases, adsorption of the gases on the surface of the adsorbent will be increases. Nature of adsorbate. The gases which are having highest critical temperature are easily liquefiable gases which are easily adsorbed on the surface of the solid or adsorbent. The sulfur dioxide is having more critical temperature, easily adsorbed. The hydrogen is having less critical temperature, does not easily adsorb. This equation you can remember, student, in PU board point of view, based on the critical temperature, they are asking the factor for 1 mark question. Next one, student, surface area of the adsorbent. Just now we are discussing, as the surface area increases, the rate of adsorption also increases. As the surface area decreases, the rate of the adsorption also decreases. Temperature. Generally, adsorption is an exothermic process, that is temperature released. Temperature will be released. If the temperature is increases, hence rate of adsorption will be decreases. Therefore, low temperatures only favorable for the adsorption of gas on the solid, because as the temperature increases, the gas molecules are disorpted from the surface of adsorbent. Desorption will be takes place. When the adsorbate molecules adsorbed on the surface, some amount of energy liberated, that is exothermic reaction. But if the temperature increases, the adsorbate molecules are separated from the surface of adsorbent, hence always low temperatures are favorable. Right, student, in PU board point of view, explanation they are not asking, simply name the factors. Write these 4 factors: nature of adsorbent, adsorbate, surface area of adsorbent, and temperature. And this application we are expecting based on the critical temperature, which gas is more adsorbed based on critical temperature. Copy this, student. Next question, student. Third question. Write any 3 differences between adsorption and absorption. First one, the molecules which are concentrated only on the surface of the substance. The molecules are concentrated on the surface as well as bulk of the substance. When you rub the board with duster, the chalk particles are accumulated on the surface only. When you dip the sponge in water, the water molecules enters on the surface as well as bulk of the sponge. It is known as absorption. It is adsorption. Adsorption is surface phenomenon. On the surface only takes place. Absorption is bulk phenomenon. Inside the substance also takes place. Inside the substance also takes place. Next one, student. It is the fast at the beginning and gradually slower. It takes place at uniform rate. It takes place at a uniform rate. Absorption is fast at the beginning. Why? Because more surface area is available, and gradually slower because surface area decreases. It takes place at uniform rate. Uniform rate, it is not fast at the beginning, it is not slow at the last. It takes place at uniform rate. At absorption will be when you dip the sponge in water, slowly the water is enter into the sponge. So uniformly the absorption phenomena will be takes place. Next question. Application of adsorption. In examination, nearly 5 or 6 applications are there, student. Based on each application, 1 mark question you are expecting. That's why you are discussing this also. Applications of adsorption. Activated charcoal is used to adsorb poisonous gases in coal mines and water fields. Generally, students, the workers wearing the gas mask, in the gas mask activated charcoal is present. Any poisonous gas releases in coal mines and war fields, then the gases are absorbed by the mask. Nowadays also we are absorbing masks, N95 mask, KN95 mask. These masks absorb poisonous gases. These masks absorb poisonous gas. This application we are expecting, student, this year, because we are using masks. Hence, on application they will expect it. In examination they will ask question like this. Activated charcoal is present in the gas mask. Soldiers are working in coal mines and war fields. What is the use of activated charcoal? Activated charcoal absorbed poisonous gases. Absorbed poisonous gases. Or name the adsorbent used in the gas masks which are used in coal mines and war fields. Activated charcoal used in the gas masks. Activated charcoal used in the gas masks. That point you can remember, student. And second application, raw sugar solution passes over the animal charcoal, becomes colorless. In the manufacturing of the sugar, the raw sugar solution containing impurities and colored that passes over the animal charcoal becomes colorless because the colored impurities present in the raw sugar solution absorbed by animal charcoal. In examination, name the adsorbent used in the sugar industry to absorb impurities from the raw sugar solution. Animal charcoal. Or what is the role of animal charcoal? Animal charcoal can act as the adsorbent. Okay, student, copy this. Okay, students, next application of adsorption. Chromatography. To separate the constituents in a mixture, we are using the phenomenon of adsorption. In chromatography, the components present in the mixture can be separated by using the phenomenon of the adsorption. In PU board examination, like this question, they will ask student, what is the principle involved in the chromatography For the separation of constituents in a mixer. Direct answer student, adsorption. Next one. Coconut charcoal can be used in the separation of noble gases like helium, neon, argon, krypton, xenon at different temperatures. The mixture of noble gases can be separated by using coconut charcoal. Next. Iron powder used as catalyst in a Haber's process. The mixture of nitrogen gas and hydrogen gas combine to form ammonia in Haber's process. In this process, the iron powder can act as catalyst which can act as adsorbent. That is, the nitrogen and hydrogen gas can act as adsorbate and adsorbed on the surface of iron powder. These applications more concentrate student. Next, fifth question. Differences between physical and chemical adsorption. Based on the nature of the interaction between adsorbate as well as adsorbent, the adsorption is of two types student, physical and chemical adsorption. First one, in physical adsorption, weak van der Waals forces are present between adsorbate and adsorbent. In chemical adsorption, it involves strong chemical forces between adsorbate and adsorbent. Physical adsorption will be reversible. That is, adsorbate accumulate on the surface and adsorbate separated from the surface. That is, physical absorption will be reversible in nature. The chemical absorption will be irreversible in nature. Once the adsorbate accumulated on the surface, it is not possible to separate from the surface of the adsorbent. It is irreversible. Only adsorption takes place, desorption does not take place. In physical absorption as well as desorption both takes place simultaneously at a time. Both takes place. Physical absorption is not specific in nature. That is, all type of adsorbate adsorbed on the surface of adsorbent if surface is available. It is not specific in nature. There is no any special condition. These gases only adsorb, these gases are not absorbed. But chemical absorption is highly specific in nature. Particular gases only adsorbed on the surface of adsorbent. Why? Because these are chemical forces. Chemical forces are present between the particular substances only, but not all substances. Hence, chemical absorption will be highly specific in nature. Particular adsorbates only adsorbed on the surface of adsorbent because it involves chemical forces. The chemical forces are present between particular substances only. Enthalpy of adsorption is low. That is, the amount of heat energy liberated when adsorption phenomena takes place are known as enthalpy of absorption, which is low in the case of physical absorption because it involves weak van der Waals forces. Due to weak van der Waals forces, very less amount of heat energy will be liberated. Hence, enthalpy of absorption will be low. That is only 20 to 40 kilojoules. Whereas in chemical absorption, enthalpy of absorption will be high. That is 80 to 240 kilojoules. Here, in the case of chemical absorption, strong chemical forces are present. Hence, more amount of energy liberated. Physical absorption will be multi-layer absorption. Multi-layer means adsorbate. First layer of adsorbate and second layer, third layer. Like in layer wise, the absorption will be takes place. Physical absorption will be multi-layer absorption. On the surface of adsorbent, adsorbate molecules are adsorbed in one layer. On the first layer, another layer will be absorbed. On second layer, another layer will be absorbed. That is known as multi-layer absorption. Whereas chemical absorption will be unimolecular layer absorption. Only one layer absorption phenomena will be takes place. That is unimolecular layer absorption. Physical absorption, low temperatures are favorable. Chemical absorption, high temperatures are favorable. Because of weak van der Waals forces at high temperature, the van der Waals forces are broken. Hence, low temperatures only favorable. Whereas chemical absorption, high temperatures are favorable. In case of physical absorption, activation energy is low. Activation energy will be high. Because of weak van der Waals forces, activation energy will be low. Because of strong chemical forces, activation energy will be more. More energy is required for chemical absorption, less energy is required for physical absorption. These are the main difference, student. It is one of the expected question PU board point of view. Any 4 or 5 differences you will more concentrate, you will get good marks, students. Okay, copy this. Okay, students, next question. Define adsorption isotherm. Explain Freundlich adsorption isotherm. The curve obtained by plotting graph between rate of adsorption x by m against pressure at constant temperature are known as adsorption isotherm. The curves obtained by plotting graph between x by m against pressure at constant temperature are known as adsorption isotherm. The Freundlich adsorption isotherm is given by x by m equal to k into p to the power of 1 by n, where n is greater than 1, x is amount of gas adsorbed, m is mass of adsorbent which provides surface area, x by m is known as rate of adsorption, p is known as pressure of adsorbate, k comma n are empirical constants, The Freundlich adsorption isotherm is given by x by m is equal to k into p to the power of 1 by 1. Term explanation they are asking student in PU board. Amount of gas adsorbed is x, mass of adsorbent is m, pressure of the adsorbate p, k comma n are empirical constant. It is in the form of y is equal to mx. If you plot the graph between rate of adsorption on y-axis, pressure on x-axis, hence the nature of the graph will be like this at a particular temperature. Apply logarithm on both sides. That is log 10 x by m is equal to log 10 k into p to the power of 1 by m. Apply logarithm to this equation. Log 10 x by m. It is in the form of log a into b. That is log a plus log b, log k base 10 plus log p to the power of 1 by n base 10, Copy this, student. Okay, students, next continuation. Log x by m base 10 equal to 1 by n log p base 10 plus log k base 10. It is in the form of y is equal to mx plus c. If you plot graph between log x by m on y-axis, log p on x-axis, the nature of the graph will be like this with a slope 1 by 1 and a y-intercept log k base 10. Next, explain shape selective catalysis. The catalysis, which depends on pore structure of catalyst, size of reactant and product molecule, are known as shape selective catalysis. The catalysis, which depends on pore structure of the catalyst, that is structure of the catalyst, size of reactant and product molecule, are known as shape selective catalysis. The good example for shape selective catalyst is zeolites are good shape selective catalysis because of their honeycomb like structure. Very repeated question, student, in one mark questions. Why zeolites can act as good shape selective catalyst? Because of their honeycomb like structure. Zeolites are aluminum silicates with aluminum oxygen silicon structures. Sometimes in examination. What are zeolites? Zeolites are aluminosilicates with aluminum oxygen silicon structure. Copy this, student. The next, students, uses of zeolites. The important zeolite used in petroleum industry is ZSM5. The full form is zeolite sieve of molecular porosity 5. ZSM5 can be used for the conversion of alcohols into gasoline. Gasoline means petrol, diesel and mixture of hydrocarbons, etc. In examination they will ask, name the catalyst which can be used for the conversion of alcohols to gasoline. ZSM5. Zeolites are used for removing permanent hardness of water, that is the calcium plus 2, magnesium plus 2 ions of hot water are adsorbed on the surface of the zeolite catalyst. The calcium +2 and magnesium +2 are responsible for the hardness of the water, which is known as permanent hardness of water. They can be removed by using zeolite catalyst. That is, zeolites are used for removing permanent hardness of water by removing calcium +2 and magnesium +2 ions. In this phenomena, these two ions are adsorbed on the surface of the zeolite catalyst. These two are applications. Okay students, with this adsorption phenomena as well as catalyst phenomena completed, the last topic in this is colloids. In the second video we are discussing. Okay students, in the catalysis topic, homogeneous and heterogeneous all topics are deleted except shape selective catalysis. That topic only you will prepare. And in adsorption phenomena, only few topics are deleted. The deleted topics we are not discussing. Therefore, adsorption catalysis is completed and colloids in the second video we are discussing.